So next is the area 4 of the domain 5 of the Network Plus certification, which is the given a scenario, troubleshoot common wireless connectivity issue. So again, I will be commenting on the video of Professor Messer entitled Common Wireless Issues and 10008 CompTIA Network Plus 5.4.
One problem you often run into on wireless networks, especially wireless networks that have a lot of different access points around, is overlapping channels. Anytime the channels are overlapping, you're creating interference with other access points in the area. This is a 2.4 gigahertz frequency distribution. You can see channels 1 through channels 11 are what's available in the United States, and you can see that 2 access points have been put onto this network, one on channel 6 and one on channel 11. You can see that the bandwidth used by each individual access point expands to the left and the right of that channel number, and that's why we always recommend that you have an access point on channel 1, channel 6, and channel 11 in the United States to avoid any type of overlap with your frequencies. Here's what can happen if you add another access point that doesn't take into account these existing frequencies. You can see this access point has been added on channel 8, which obviously is going to overlap with the access point on channel 6 and the one on channel 11. This is probably going to cause all of these networks to perform poorly, and it would have made more sense to put this new access point down on channel 1 where it would not overlap with the access point on 6 or 11. If you've ever worked on a wireless network, you know the farther away you get from that access point, the less signal will be available, and your network connection will probably run slower. This is because as you move farther away from that antenna, there will be attenuation as that signal gets weaker and weaker. If you need to see exactly how much attenuation, you can check the local statistics on your wireless receiver or check with an external Wi-Fi analyzer. You may be able to control the output of the power on your access point. So if you need to increase the signal strength so that one particular area is able to connect better, you may be able to increase that on the access point. Not all access points have that functionality.
So for the access point, ang access point kasi is it allows you to connect wirelessly dun sa router natin. So many configuration ang meron sa access point. But it can be it can be configured through doon sa mismong router natin. Kapag lumang router ang gagamitin, you must reset it, and kapag bago naman, pwede kang pumunta lang sa settings to configure it as access point. Meron tayong 2.4 gigahertz. Yun yung pwede mo siyang ma-access wirelessly kahit nasa malayo ka sa router. And meron din tayong 5 gigahertz. Yun naman is kailangan nasa area ka na malapit sa access point para yung speed na internet connection mo is mabilis.
So make sure you check the documentation of your access point. You also might be able to replace the antenna that's on your access point with one that provides more gain. A higher gain antenna may increase the signal strength on the access point, and some wireless access cards support adding an external antenna, so you might be able to add an additional antenna on your desk to be able to receive the signal better. There's also some signal that's lost in the coax between the access point and the antenna. The amount of loss increases as you increase the frequency. So 5 gigahertz frequencies will have more loss in the coax than 2.4 gigahertz. You should also check and make sure the cable itself has not been damaged, especially if you have connections that are outside and are subject to being damaged by the weather.
So yung connection lang ng router, meron tayong 1 port at saka LAN port. 1 port is for the wireless connection, and then yung ating LAN port is for the wired connection.
When you first configure an access point, you assign it a name. This name is the Service Set Identifier, or the SSID. And on a very busy network or an area with many different access points, you might inadvertently be connected to the incorrect access point. If you've ever been in a public area with a lot of access points, you might have the choice to choose between public Wi-Fi internet, guest internet, and internet, all three different wireless networks. And looking at those names, it may not be obvious which one you should be connecting to. This might also be a security concern because you don't want to connect to a third-party access point, especially if you're sending non-encrypted data. So make sure you confirm what the right SSID should be and that you're selecting that particular SSID in your wireless configuration.
So example lang ng SSID is yung pangalan ng mga routers natin. For example, I have here my router with that has the SSID TP-Link CDF2, and our router is PLDT Home Fiber. So as you can see, meron siyang 2.4 GHz frequency and 5G frequency. So yeah.
If you're in a public area, you may be connecting to an open access point. But in your office or at home, there is authentication that must occur so that only authorized users gain access to that network. There may be different ways to connect to the network depending on where you are. If you're at home, you're probably using a PSK or pre-shared key so that everybody uses the same passphrase. But at work, you may have a username, a password, and perhaps some other type of authentication factor. If you're at home, it's easy to troubleshoot this by making sure that everyone knows what the correct pre-shared key happens to be. But in the enterprise, you need to make sure that the network access control or the 802.1x system is all working as expected. You need to make sure that your access points or wireless controllers can communicate properly to your authentication database, and then you need to make sure that each user has the correct credentials to allow them access to the network.
So meron tayong tinatawag na public Wi-Fi. Yun yung mga walang password na Wi-Fi connections. Meron din tayong tinatawag na may password yung mga Wi-Fi. It is secured password. Secured Wi-Fi connection. Yun yung merong password na pwede natin hingin yung password sa may-ari. And meron din tayong tinatawag na whitelist. Yun yung open yung network, pero naka-configure doon sa my router yung mga pwede lang makapag-access nung internet connection natin.
When connecting from a wireless device, we need to make sure that the encryption we're using on that device is the same as the supported encryption types on the access point. If those have a mismatch or there's not a compatibility between those devices, your device will not connect to the wireless network. Now that WPA2 has been out for so long, it's difficult to find devices that can't support a minimum of WPA2. But you may find that you have a legacy device that simply doesn't have the technology to connect to a WPA2 or a WPA3 wireless network. In those cases, you'll need to make a decision as to what you'll do with that particular legacy device. It may be that there is a wired option, or you may have to use a different access point to allow that legacy device to connect. And if this is a very old wireless device that can only support wired equivalent privacy or WEP, you may consider not connecting that to a network until you're able to provide a firmware or hardware upgrade for that device. As we mentioned earlier, managing the frequencies on your wireless network can be a challenge. You want to be sure that all of your access points are sending a signal that is not going to overlap with an access point that's nearby. This interference may cause poor throughput, or you may find that some devices aren't able to connect to the wireless network at all. You'll want to see which frequencies happen to be used by the access points and be able to find frequencies that don't overlap with each other. This can be a challenge at 2.4 gigahertz because we only have so much frequency available. At 5 gigahertz, there are many more frequencies available, so it may be easier to find an open channel. If you had a floor of a building and you had 7 2.4 gigahertz access points, you would need to place those access points in a way that it would not overlap with these channels. You should plan on implementing channel 1, channel 6, and channel 11 because those three channels do not overlap with each other in 2.4 gigahertz, and then make sure that all of the channels are not overlapping with each other. You can see that channel 1 does not overlap with each other, channel 11 is separate from each other, and channel 6 does not touch channel 6. This ensures that there will be no interference between any of these access points, and you'll have the fastest throughput possible. You've probably seen Captive Portal when you first connect to a wireless network, and it puts a prompt up asking you for a username, a password, or to that you agree to the rules and regulations on this wireless network. This Captive Portal is created because your access point has a list of all of the devices that have already authenticated to the network. And if your device has not already authenticated, it puts this Captive Portal prompt so that you can then use a username, password, or some other type of authentication to gain access to the wireless network. Normally, this authentication process has a certain time frame. So once you authenticate, you may be allowed on the network for 6 hours, 12 hours, or 24 hours. Once that time frame has elapsed, you'll be presented again with another Captive Portal screen where you have to authenticate again for that particular time frame. If you're using a username and password to authenticate to the wireless network, then there's probably an authentication database in the back end. This might be LDAP accessing an Active Directory database, it might be Radius or TACACS, and if someone's not able to authenticate properly, you'll have to check their credentials on that authentication database to be sure they're using the proper username, password, or any other authentication credential.
Example nito is yung sa school, which is the public Wi-Fi doon, yung smart, ganun. So, if you wanted to connect kung gusto mong makomonect doon is meron ng authentication and may limit lang din siya na 1 hour or 30 minutes. And yun yung pinaka-example nito.
On some older wireless networks, you may find a problem associated with client disassociation. This is a denial of service attack that prevents people from accessing the wireless network. They might be working. Some older wireless networks, you may find a problem associated with client disassociation. This is a denial of service attack that prevents people from accessing the wireless network. They might be working just fine on the wireless network and then suddenly their device will disconnect. As long as someone is sending these disassociation frames, that machine will not be able to communicate to the wireless network. If you're wondering if your issue is associated with a disassociation attack, you can get a packet capture with Wireshark and look at the 802.11 frames. It should be very easy to see the disassociation frames in the packet capture. There are really two ways to resolve a disassociation attack. The first one is to remove the device that is performing the attack. That would effectively allow people access to the network again, but a better solution might be to upgrade to one of the latest 802.11 standards, which has resolved this problem and prevents any type of disassociation attack.
So, that ends the discussion of the Area 4 for the Network Plus certification.